Okay, this section in chapter 6 deals with finding the foot of perpendicular from a point to a line. Okay, so in order to understand this, okay, we have to run through an example. So what you have here is that I have a point, and then I've also given you the equation of the line. Question say find the foot, the point F, such that F, which is on L, is in a situation by which AF is perpendicular to L. Okay, so let's put everything together diagrammatically. You have a point A, you have the line L, okay, given here, and then you have point F on L such that AF is perpendicular to L. So for sure, F must be directly, you draw a vertically down, a line down, and then make sure that this is 90 degree. This is your position of your F. So diagrammatically, this is what is happening, and your job is to find for me the position vector of F. Okay, so first method is what we call the projection method. So I need you to understand, or rather recall, your chapter 2, your projection formula. To find the projection, okay, your formula for projection is A dot B hat B hat. This is the formula for projection. So referring to this diagram, okay, look at this triangle down here that we have. Okay, can I assume that this point C is somewhere on the line, and I say that this is 80 minus 1. So you'll be asking me, where does 80 minus 1 come from? It's just this point, a point on the line. So I just say point C, let point C be 80 minus 1. So I have OC, I have OA. What else is available? I have the direction vector of the line. So I'm going to say that direction U, negative 614, this direction vector of the line, is in this direction. Okay, and if I know what is CA, CA dot with U hat will produce for me CF. This is actually your projection formula. Okay, so you need to recall your projection. Okay, CA dot with this direction divided by its magnitude will produce for me CF. This is from your chapter 2. So what I need to do now is I go and find CA. CA comes from OA minus OC, and CF is the projection of CA onto line L. So I have CA here settled already. What's U? What's U hat? This is U. Divided by its magnitude, I'll get my U hat. So put in everything numerically, I can find CF vector as this item. So if this is CF vector, I can work backwards and find what is vector OF, and that will be the coordinates of my point F. This is your projection method to find the foot of perpendicular from a point down to a line. There's another method. Okay, so the other method is that you need to use your line concept. F, okay, this is the foot of perpendicular. F is on the line L. So I can say that OF will actually have the same equation as your equation line L. The only difference is that this time around T takes a specific one value. So I can say that OF is equal to this formula for a specific T. So OF is this have this so-called vector, position vector. Can I find what is AF? AF comes from OF minus OA. This is OF, this is OA. Okay, put in everything numerically. This is actually AF. And next, look at what I have now. I actually have AF. I actually have the direction vector of the line. They are perpendicular. So what happens when something is perpendicular? Dot product equals to 0. So since AF is perpendicular to L, AF is perpendicular to the direction vector of the line L. So AF dot width direction vector of the line L must be equals to 0. Okay, AF dot width direction vector of line L must be 0. So fit everything numerically in, you solve for t equals to 1. So what to do with this t equals to 1? Substitute back into this formula, because I say that OF is for a specific t, and then you found that specific t to be 1, and that is your coordinates for your point F. Okay, so with this concept, we're going to extend a little bit into the reflection of a point in a line. So what happens here, if this is your point P, this is my line L, where is the reflection of a point in a line? So you must understand they must have equidistance. If this is point P, the reflection will be point P prime. And then if they are equidistant, you can actually activate your ratio theorem and say that PP prime, okay, is actually PF 2 times. Okay, so F divides PP prime into the ratio of 1:1. You can actually find ratio theorem. So how are we going to understand this? We use an example, and then we're going to do this very quickly. We extend from example 5. So let's recall what we have in example 5. Example 5, we actually found the foot of perpendicular from point A to the line L. So diagrammatically, I have already found this coordinate. Okay, I have this coordinate, I have this coordinate, I found this coordinate. My next objective is to find this A prime. Okay, so if they are equidistant apart, okay, can I just use ratio theorem? That means OF is equals to OA plus OA prime over 2. And then put in everything numerically, you actually have found the so-called reflection of your point A in the line L. So the main skill involved when you talk about reflection is your chapter 1 ratio theorem.